Hi, AP Chem students. This is Ms. Schmidt, and I'm doing a short video on the data analysis for LAB4, the cell phone spectrophotometer lab. So first of all, for the wavelength of light used, we want to put in the light that was transmitted through your food coloring solutions. So this is for yellow food coloring. So I chose 440 nanometers, which was blue light. So that's completely blue. The RGB value is 255, and 255 is the maximum intensity for this blue color. So you put in the wavelength right there, and then I put in the color of my food coloring right there. And then you set up your data table for your different solutions, your 5 different solutions, and enter in the data values for your 3 separate readings. Now, over here, you're going to average your 3 values. And the way to do this is use the formula average. And you can drag over the values you want to average. And when you press return, it gives you the average, and then you can pull down this little blue square right here, pull that down over the different concentrations, and it gives you the average for that. Now, to get the absorbance, we have to use the absorbance equation that involves the transmittance of the light through the solution. So that was equal to you could just put that formula in. So equals minus log, and you want the intensity of the solution that you're looking at. So we'll use the average value here, and then divided by the value for the solution that has no food coloring in it. So just the water by itself. So you want to get 100% intensity for that one, or at least what the water reads. So I'm going to just put that in as a value, 254.6666667. And because I don't want that to change. And as you can see, the absorbance is 0, as you would expect for light being transmitted through water. All right, so then I'm going to drag my blue square down over these other cells so that I can get the absorbance for my other solutions. So now we have to graph. So we want to graph the concentration, put that here, versus the absorbance. And I'm going to copy this. But when I paste this in, I just want the values. I don't want it to do new formulas. So I'm going to right-click, paste special, paste values only. And that just gives me the values over here. So now I want to graph this data right here. So I just select this data and go down here where it says Explore. So click on Explore. And I want a scatter plot of my data to see how well it makes a line. So I just click on that graph and I bring it over. And so now I see my 5 points, and they look like they might make a pretty good line. But what we want to add is a trend line and the actual equation of that line into my graph. So you have to double click on the graph. It will open up the chart editor, click on Customize, then scroll down and find Series and open that up. Then you want to scroll down here until you find Trend Line and click that. That puts a best fit line using your 5 points. So there's the trend line. We also want the equation for this line so that we can use our equation to figure out the concentration of an unknown. So under label, click that and click use equation. So now we have the equation showing up. Let me move the graph over. So there's our linear equation, y equals mx plus b. And then if you click on show r squared is 0.963. That gives you a measure of how well this line fits your points. The closer it is, closer r squared is to 1, the closer your line fits your 5 points. You can close the chart editor, and so that's it. And this technique is used all the time in pharmaceutical companies, any sort of analysis, analytical chemistry companies, engineering, environmental. It's a standard technique used to find the concentration of a solution where you don't know the concentration. You make a standard curve like this, and then you're able to use this linear equation to solve for the concentration of something in an unknown solution. Okay, hope this helps.